It's math mix-up. Everybody's math. Gotta love the teacher. You happy? Miss Lowry. She teaches 2 plus 2 and crazy formulas. You be going home to mom and dad saying, yo, I love math. And the teacher is hot. She got me memorizing algorithms. I'll be up all night. Cause math is crazy. It's math mix-up and I'm peacing out.
The following problem is about Adam and Sierra. Sierra is in a burning building. She has her head out the window and she is screaming at the top of her lungs while holding onto her pet Rottweiler Fuzzy. The young, handsome fireman, Adam, hears her cries and races to her rescue. He places a 10-foot-long ladder 3 feet away from the bottom of her building, and it reaches directly up to her window. He climbs up and reaches for Sierra. Fuzzy doesn't like this, and he lunges for Fireman Adam's neck. Adam falls to the ground from the top of the ladder. How far does Adam fall to the nearest 10,000th of a foot? Okay, let's draw what's happening. Here's the building. Here's Sierra. Her head's out the window. She's holding on to Fuzzy. There's Fuzzy's teeth. Yeah, there's the ladder. Adam has put it against the building. There's Adam. He's climbing up to get to Sierra. Let's see, what else do we know? The ladder's 10 feet long, so we'll mark that as 10 feet. And the base of the ladder is 3 feet from the building. He's climbing on up here. When he gets up here to the window, Fuzzy jumps at his neck, and the poor guy, he goes, whoo! He falls. Our sides, let's see here now. The short side is side A, that's 3 feet. The length he falls is B, we don't know that. The longest side is 10 feet because it's across from the right angle. That's the hypotenuse, that is C. All right, our formula is a squared plus b squared equals c squared. That's the Pythagorean theorem. We're going to use this to find out how far Adam fell. The ladder was 3 feet away, so that's side A, so that's 3 squared, plus the b squared, the distance he fell, we don't know what that is, plus the length of the ladder, which is c, so that would be 10 squared. All right, 3 squared is 9, plus our b squared equals, let's see, 10 squared is 100. All right, now we've got to get that b squared by itself. We need to get that 9 out of there. So we're going to think about it. How do I get, it's being added right now, how do I get rid of 9 added to the b squared? Well, let's think about this. If we subtract, yeah, subtract it away and then I'll be left with b squared. But then I'm going to have to subtract it from the 100 as well. So we'll go ahead and do that to the same side of, to both sides of the equation. We'll subtract the 9 and we will be left with b squared equals 91. All right, let's see if we can get a visual on this. B squared is 91. So if we draw a big square off of the b side, its area would be 91 square units. All right, but I don't really want the area off of the b squared. I want to know how far Adam dropped. All right, we need to find b. And to do that, we're going to have to take the square root of 91. And the problem says to take it out 4 decimal places to the nearest 10,000th. So when we use our calculators, the square root of 91 out 4 decimal places, let's see what we're going to get. Let's see here. Looks like 9.5394 feet. This problem is about Brittany. Brittany works for the Sega company, designing the play screens of some of the world's best-selling video games. She's working on the final scene of her latest game called Schmelda Strikes Back. Schmelda is about to be destroyed by the ancient Icosmatron Queen. Schmelda must jump along the diagonal path of the rectangle with the coordinates you see below. Oh, will she make it? We need to find the length of the diagonal to the nearest tenth of a unit. All right, let's draw this grid. See what Schmelda's up against. We've got our x and our y axis. We'll go ahead and put some tick marks on it. And we'll place the dots to represent where the Icosmatron Queen and where Schmelda are. And we will form a rectangle. Now, we've got to find the coordinates of these vertices.
Coordinates on a grid are always listed with the x coordinate first. So along the x-axis, we're going 1, 2, 3. So this right here will be a 3. And then we're going up 1, 2, 3. So that will be a 3. The coordinates of this point, we're going 1, 2, 3. We're still going 3 over on the x-axis. But this time we're going down 1 on the y-axis. So that would be -1. Will be -5 for the x, and 1, 2, 3 on the y-axis. The final one, can anybody tell me what this one would be? Kiana?
-1.
Yeah, but that's on the y-axis.
Yeah,
What's this one going to be?
4.
-5.
Yeah, -5.
Yeah, because we're over in the negative direction.
Now Schmelda is going to jump from here to here, a diagonal jump. We have to figure out the length to the Icosmatron Queen. We're going to have to do that by using the Pythagorean theorem. We've got a right triangle here.
Comes a right angle problem, a Pythagorean theorem problem. We're going to let this be side A, we'll let this be side B, and the thing we're looking for is going to be C, the hypotenuse. Where is it from this point to this point? Well, let's look. You're down here at -1, and we're going to jump up here to +3. So, how long is it from here to here?
3.
No.
Or no. 4. Yeah, 4.
4. So A is 4 units long. Over here to this corner, it's straight across. We're at +3, and then we end up at -5. How many jumps is that? 8. Good. So B is equal to 8.
Okay, let's start with the equation. A squared plus B squared equals C squared. And we know our A is 4, so 4 squared, plus our B of 8, which is 8 squared, equals C squared. Alrighty, now 4 squared is 4 times 4, which is 16, plus 8 squared, which is 8 times 8, which is 64, and of course that's all equal to C squared. Now we add these two, 16 plus 64 gives us 80, and then 80 is equal to C squared.
So here we have that big square that's off the C, all this area right here is 80. But I don't want the area. I just want to know how far Schmelda has to jump.
To find how far she jumps, we've got to take the square root of 80. Oh, yep, that's what the distance C will be. Now, rounded to the nearest tenth, like the problem says, will be 8.9 units. So we're going to put approximately equal to C.
It's math mix-up. Everybody's math. Gotta love the teacher. You happy?